So I just want to spend a little bit of time going through the need and use of a continuity correction. Whenever we approximate from a discrete distribution into a continuous distribution, we need to apply a continuity correction. If you remember, a discrete distribution only takes specific distinct values, whereas a continuous distribution can take any value within the specified range. So, with a discrete distribution, there are gaps between each value. But a continuous distribution, there are no gaps. So a discrete distribution can be represented by these points, these dots, whereas a continuous distribution would be represented by the line. Each dot corresponds with a line segment which goes in between the bounds of the number that the dot represents. So the dot for the value 17 represents the bounds of 17, 16.5 to 17.5. In straight maths, the discrete distribution we work with is the binomial distribution, and we can approximate that into the normal distribution. In further maths, there are more discrete distributions to work with, like the Poisson, which also can be approximated to the normal distribution. Let's have a look at some probability statements. Well, here I've highlighted the region represented by the probability statement x is greater than 17. I need to include all of these points from 18 upwards. With a discrete distribution, there is no 17.9, there is no 18.1, there's nothing that exists in between the 17 and the 18. But if I'm going to apply a continuity correction, I do need to consider the whole range of values in between 17 and 18. And now that I've given you this visual, I hope intuition lets you know that we can use the midpoints. We can use the bounds of each of these numbers as sensible starting points when we're working with a region. So, for the probability x is greater than 17, the continuity correction should be y is greater than 17.5. We started at the midpoint of 17 and 18. A useful tip to make sure that we get this correct is to ask yourself, does the 17 and its interval of values need to be included? The 17 didn't need to be included, and neither did any of the values in between its bounds. Okay, so let's just change that a little bit. This time we'll make it the probability that x is greater than or equal to 17. So we are going to include the value 17, and as we apply the continuity correction, we're going to include the values within its bounds. So the continuity correction will be highlighted all the way from 16.5 upwards. So the continuity correction being applied gives us the probability that y is greater than 16.5. This will work exactly the same way with less than probabilities. If I have the probability that x is less than 23, I'm referring to all the values that are smaller than 23, so that's 22 and below. If I do the same sort of highlighting on a continuous spectrum, I'm referring to all of the values less than 22.5, using the bounds once again. If you have this image in your head, I think the continuity correction will start to come quite quick and naturally to you. Ask yourself whether or not these values are involved. So, a two-sided inequality this time round. The 16 is included and the 22 is included. I've represented that with the yellow highlighting here. The corresponding continuity correction probability statement is going to go from 15.5 to 22.5. Probability that y is in between 15.5 and 22.5. Once again, checking what's included and what's not included. This time around the 16 wasn't included, but the 22 was. The value to use for the continuity correction should not include the number 16. So we'll start above 16 at 16.5 and we'll once again go all the way up to 22.5. Okay, here again, 16 is included, 18 is not. So on our continuity correction, it's 15.5 up to 17.5. So hopefully this visual diagram in your head, or even writing it out if you need to, can help you to do the continuity correction correctly. What if the discrete distribution was exactly equal to one value? So the probability that x equals 18 Well, I hope you can see right here that yes, we're going to need to use the bounds of the number 18, the probability that y is in between 17.5 and 18.5. So, even though this was an equals to one distinct value, we still had a range of values on the continuity correction. So here we go again, similar situation. What are the range of values? I'm interested in this whole line segment from 22.5 to 23.5. So to summarize, anytime that you are approximating from a discrete to a continuous distribution, you should be applying a continuity correction. The continuity correction accounts for the fact that a discrete distribution has gaps in between the values it can take, whereas the continuous distribution that we're approximating to does not have the gaps. To deal with this situation, we need to make sure that we are using the entire interval as necessary. We make use of the upper and lower bounds of the values that the discrete distribution can take. A key question to ask yourself is whether or not the limits or the boundaries for the discrete probability statement are to be included or not to be included. And that helps you to determine the values you should use for the continuous distribution probability statement. So have a go and get some practice in. And if you like, you can re-watch and see if you can anticipate what the continuity correction probability statement will be.